All right, guys, we're in week 17 here. We're going to be going over a new learning target, 6.3, evaluating functions and function notation using equations, tables, and graphs. So there's a lot going on in here. Mostly what we're going to be focusing on is the evaluation piece, uh, what it means to evaluate from a table, from an equation, from a graph. But also there's some ways that we write things in math that are going to have to be learned in order to be able to do these things. So you can see here we have some pictures of functions in different ways and some notes about them. Right down here we have something that isn't written in an equation form that is a function. We'll go over kind of what these different things mean, but just to talk about it briefly, this is the name of the function f. X is our input variable, and then over here this is kind of our output, what our function is supposed to do. And here are some examples of evaluating it. Evaluating it for an input of 2, we get an output of 7. Evaluating it for an input of -4, we get an output of 11. We'll go over this stuff a lot more in depth in the next few slides, but just kind of a preview. And here we have some different colored functions here, different colored graphs. The function f is represented with this blue parabola, g is represented with this red parabola, and then t is represented with this green parabola. Just kind of a preview of some of the things that we're going to be talking about. All right, here's a quick warm-up. Feel free to pause it. This goes over learning target 6.1, describing graphs. Again, feel free to pause it. I'm going to go ahead and go through the answers here real quick. So first of all, shape. This is an absolute value graph. Has that V shape. Increasing, decreasing where? So this graph begins by decreasing. Remember, we start by reading the graph from left to right. So it starts by decreasing, and then it's increasing. But we want to be specific with this. So it's decreasing until this point on the x-axis, -4. Decreasing. Decreasing until x equals -4. Until x equals -4, then increasing. And that's what's happening. We're following from the left to right, so we use that x-axis as our guide. We're decreasing, decreasing, decreasing. We stopped. We're at -4, and now we start increasing. All right, the next thing we have here are the intercepts, x-intercepts and y-intercepts. So remember, the x-axis is our horizontal axis. I'll go ahead and highlight that. This pink color, that's our x-axis. We're looking for the places where our graph crossed that. So right here and right here. The coordinates for that are going to be -6, 0 and -2, 0. Notice with x-intercepts, the y-coordinate is 0 because we're not going up or down at all. We're just moving along the x-axis. And then y-intercepts, so the y-axis is our vertical axis going up and down. I'll go ahead and highlight that in yellow. So that's our y-axis, and our graph crosses that in one place, and we can see that right here. So that point is 0, 2. The x coordinate is 0 because we're not moving left or right. We're only moving up and down along the y-axis, so 2 is our y-coordinate. And then do we have a minimum or a maximum or neither? In this case, we have a minimum point. We have a lowest point. We do not have a highest point because we have to assume that this graph keeps going up forever on both sides here, so there will not be a highest. And the coordinates of this minimum has an x-coordinate of -4 and a y-coordinate of -2. So we have a minimum, no maximum, at -4, -2. Right, let's go ahead and move on to the content for today. Okay, which graph is which? How can you distinguish them? Well, we can see we have a few different graphs. We have this red graph here, looks like an absolute value graph. We have this black graph, looks like a parabola, and then we have a few lines. We have a purple line, a green line, and a blue line. So one way to distinguish them would be by color, right? You could use color to distinguish these graphs. Which color are they? We could distinguish them a little bit by name or by shape, rather. That does fall apart a little bit with the lines because, you know, some of these we have multiple lines, but that works for some of them. Other than that, like, I don't know. We need a better way to do this. This is what we're getting at. So how about now? Well, now, they're all red. We can't even use color anymore. We can kind of use shape because, well, we have some different shapes, but it's even hard to tell where one graph starts and the other graph begins. This is why we need something better than color, better than shape to talk about them. And we give them names. And we name them just with a single letter. So this is function notation. It says a function of x. F is our function of x. G is our function of x. H is our function of x. P is our function of x. And D is our function of x. So we give them these letter names, F, G, H, P, and D. That way we can easily distinguish them. When I say function F, I'm talking about the red one. When I say function H, I'm talking about the blue one. So these names are really useful. The parentheses x, that tells us what our input variable is. So our function h is a function where our input variable is x. Sometimes that input variable may change in problems that want our variables to match real world things. So if our function was relating the time worked and the amount of money earned, you may want to use a variable that matched like money. So you might use the letter M, or time, you might use the letter T instead of X for your variable, but that's small. What we're really focusing on here is the names, just so that we know which function we're talking about. Is it function F, G, H, P, or D in these cases? These first three, F, G, and H, those are really common letters that are used with functions. Otherwise, we can kind of use anything. But F, G, and H are going to be the most common ones you'll see. All right, so we can do the same thing for tables, equations, and graphs. So we can call a table, which represents a function. We can give it a name like this, like f of x. We can write an equation and call that function f of x. We can graph something and give that graph a name, f of x. So we can do the same thing for all of these things. But what about the inputs and outputs? So a function is really important to know that a function takes an input, gives us an output. So remember, when we were kind of introducing this concept of functions, we were talking about a vending machine. We input some numbers on the vending machine, and it outputs, some sort of snack, a drink, chips, candy bar, whatever, right? So these functions work a little differently than a vending machine. We input numbers and we get out other numbers. So we need some sort of quick way to know how we're writing an input and writing an output. And there's some ways that we write that in math. So we're going to go ahead and talk about that. So we have this statement right here. F of 1 is equal to 8. That's what this is reading at. It says F of 1 is equal to 8. What does that mean? What does that mean? That means if we put in the number 1 into the function f, that's what's happening right here. You can hopefully see that, right? We're putting the number 1 into the function f. So this is our input. And we're getting out the number 8. That is our output. We could write some other statements like this based on our table, but you can see right here in our function table that that's true. When we put in the number 1, we get out the number 8. Let's write another statement like this that's true based on our table. So let's go ahead and take a look at this first entry of our table, input of 0, output of 10. So if we put in 0, this is our input, we should get out 10. Or do another one, why not? If we put in 2, we should get out 6. So f of 2 is equal to 6. So this allows us to ask some questions in a pretty short manner. We could ask a question like this, like f of 3 is equal to what? If you put in 3, what do you get as an output? Well, we can see that right here. If we put in 3, we get out 4. The answer here is 4. it actually allows us to ask some other questions too. It says f of what input, what number do you put in to get out, let's say 8. So what number should I put in to get out 8? So we look through our table, we look at the outputs, and we find 8. What number do we have to put in? 1. So we say x is equal to 1. The input is 1. A lot of different questions we can ask. I recognize this is all new. We're going to keep reiterating this type of notation as we go through. So here we go. Let's just kind of summarize that again. So this is the name of the function. A lot of people will get confused with this. This is not a variable. It's just the name, tells you what function it is. It's called f. The number in the parentheses, that's your input number. What are you putting into the function? And 8, that's the output. What does it give you out? So you press the 1 button and out popped an 8. Let's evaluate this function using a table. So we have 3 different representations of functions we're going to be working with. Tables, which we've seen already. Graphs, which we've also seen already, but we're going to talk about how this works. And equations. We need to be able to evaluate all of them. So let's go ahead and go through it. This is the same table we were looking at, so it should be pretty easy. F of 0 is equal to, so this is saying if you take the function f and put in 0, what is your output? Put in 0, you should get an output of 10. F of 3 is equal to, if you take the function f and put in 3, what do you get out? You get out 4, right? 3 for an input, you get out 4. F of 1 is equal to, if you take the function f, put in the number 1, what do you get out? You put in number 1, you get out 8. Those are all very straightforward. They're asking for the output when they give you the input. We can ask this question a little bit backwards, though. We can ask, for what x, for what input, does f of x equal 6? So for what input are we going to get out 6? Where do we get out 6? We get out 6 right here. 6 is our output. The input that we used was 2. So for an input of 2, we get an output of 6. You guys try the same process on the next table right here. So let me click to the next one. So go ahead and try this different table. Try to evaluate the function and try to figure out this last question as well. Pause the video and try these problems, and then I'll go ahead and go over the answer. All right, h of -2 is equal to, so take the function h, this is the name of our function h, and put in -2. We put in -2, we're supposed to get out -10. Take our function h, put in 4, get out 10. Right, we got out 10. Take our function h, put in 0, get out -1. And we're using that table to read it. Last question, for what x, for what input, x is our input variable in this problem, for what input does h of x equal 10? So for what input do we get an output of 10? Here is our output of 10. It took an input of 4, so x equals 4. H of 4 is equal to 10. Awesome. All right, let's go ahead and talk about the second thing we can do. We can also evaluate functions that are graphs. Now, we have to remember two important things. The x-axis, right here, the yellow one that I just made, the x-axis represents our inputs, right? These are our inputs. And the y-axis represents our outputs. So I'm going to go ahead and write that also. Outputs. And every point on our graph represents a pair, an input and an output pair. So this point, for instance, right here, which has a coordinate of 4 on the x-axis and 1 on the y-axis. This represents an input and an output pair. That means when you put in when you put in 4 for this function, 4 is my input, you get out 1. That's how I read that. This point on my graph tells me an input and an output pair. When you put in 4, you get out 1. Let's just pick another point over here. Let's just say this one right here. So this one has an x coordinate of -5 and a y coordinate of 4. So this one is another input-output pair for this function. It says when you put in -5, you get out 4. I'm going to go ahead and erase those things and kind of try to answer the questions about input and outputs here. Okay. All right. Oh, I didn't mean to erase that. Okay. So here we are asking a question. We have named this function g of x, I guess. It's not stated, but we'll just say this function is called g of x. G is its name. So g of 5 is equal to what? Or sorry, g of -5 is equal to what? This is asking me if you put in, this is our input, -5. So -5 is my input. What is the output of my function? So I need to look and see where my function is right here. Here's a point that has an input of -5. What is my output? It's 4. 1, 2, 3, 4. So my output is 4. So the process that I'm doing here is I'm looking along my x-axis for where that input is, and then I have to figure out what point on my graph has that input. So I just had to go straight up there to find it. That point is -5 for an input, 4 for an output. Let's keep moving on here. G of 0, so 0 is our input, so 0 on the x-axis is right here. Again, we have to move up to find our point, and here's our point right here. This point is 0 for input and 3 for an output, right? 1, 2, 3. Our y coordinate is 3, that's the output. And then our last one, g of 4, and 4 is our input. So 1, 2, 3, 4 is our input. Here's the point on our graph that has a coordinate of 4 for input, and its output here is 1. We have to go up 1. So the output is 1. This is a little bit trickier, a little bit more difficult. Okay, I'm going to go ahead and clear this screen, move on to another one that you guys can practice. All right, you guys try this. I'm not sure that I like that this has 2 different graphs here, but let's be careful here. It says f of x is in blue, so it's that line, and g of x is in green. That's our parabola, okay? So I'm going to do the first ones that are using f of x first, okay? Just to keep things simple, f of x is in blue. So I'm going to do these 2 problems that ask us about the blue graph. Again, I don't like that it's different, but that's okay. We're just pretending that blue is the only one on there. So we're saying, what is f of 0? So 0 is our input. That is our x value. So 0 on the x-axis. Where is our graph? Our graph is up here, is the point that has a point 0, comma what? 0, comma 2. So 2 is our output. Let's go ahead and answer this one again. F of -1. Okay, -1 on my x-axis is over here. We had to go to the left one. To get to our graph here that has that point, we're going to go down a little bit, right? Right there. So this is -1 for our input and -1 for our output, right? We had to go down 1. So -1, -1. That wasn't so bad. Let's try another one on f. Let's just pick another random number. Let's just say, I don't know, let's just find f of 1 just to mix it up. All right, so f of 1. So we got to go over 1, positive 1. And we have to figure out the point. So our graph at 1 is all the way up here. So our output there is 5. Because this point is 1, comma 5. Input of 1, output of 5. All right, so 2, -1, 5. That's what we got there. Let's go ahead and clear this. And now let's focus only on the green graph. So we're going to be looking at these 2 problems right here. And I'll probably make up another one just to talk about it. G of 0. So our input again is 0. We're looking only at the green graph now. G of x is green. So we need to go all the way up here to find a point that has 0. It's 0, comma 1, 2, 3, 4, 5, 6, 7. 0, comma 7. So that's that output there. G of 2, so we got to go over 2. Right here is 2. Our graph that has a coordinate of 2 is right there. This point is 2, comma 3. So our output here is 3. Let's go ahead and do another one. Let's do G of negative 3. Okay, so the input is negative 3. So we're going to go 1, 2, 3 to the left to get to negative 3. And then we have to go down, down. Right here is a point that has a coordinate of negative 3. It's negative 3, comma, right here, negative 2. So our output is negative 2. So again, the x's are the inputs, the y's are the outputs. So when we're asked to evaluate G of 2, we go to 2 on the x-axis, figure out where the graph is there, and figure out what that coordinate is. It's 2, comma what? And then for us, it was 2, comma 3. So 3 was our output. This one is probably one of the more challenging ones that people do mix up here and there. All right. The last way that we need to evaluate a function is evaluating functions that are equations. So let's start with this equation right here. We have g of x, so our function name is g, and our function is 4x minus 7. So we're going to evaluate it. What it means to evaluate a function is we are replacing x with this number, right? The x becomes the number that we want to put in. So g of 3 means that I put a 3 where the x is. So this, instead of being 4 times x minus 7, it becomes 4 times 3 minus 7. And then I have to do my calculations, paying attention to order of operations. So here I have multiplication and subtraction, so I'm supposed to do the multiplication first. 4 times 3 is 12, minus 7. 12 minus 7 is 5. So here is our output. So evaluating a function becomes performing calculations. We put a number in where the x's are. We perform our calculations following order of operations, and we should get out a single number. Let's go ahead and try this again for negative 1. So again, we're going to replace x with a negative 1. So it becomes 4 times negative 1 minus 7. Again, we have multiplication and subtraction. We need to do this multiplication first. 4 times negative 1 is negative 4 minus 7. Negative 4 minus 7 is negative 11. So negative 11 is our output. It's not too hard. It just becomes a matter of calculating this. If you're not sure how to follow order of operations accurately, make sure you are using a calculator to double check that. All right, let's go ahead and try that one more time. Last time, so you guys try it. Feel free to pause the video here. We have our function f, which is 2x plus 1. You need to evaluate f of negative 3. So negative 3 is our input, and f of 5, 5 is our input. Okay. I'm going to go ahead and do this. Again, we're replacing x with these input numbers. So f of negative 3 means to do 2 times negative 3. Right? Instead of the x, we're putting a negative 3 plus 14. Again, we have multiplication and addition, so we need to do the multiplication first. Negative 6 plus 14. Adding those together, we get an output of 8. So an input of negative 3, an output of 8. On the graph of this function, this would be a coordinate point, right? This would be a point somewhere on my graph, at negative 3, 8. Last one, f of 5, so we're going to input 5, becomes 2 times 5 plus 14. Again, multiplication first, 10 plus 14, that equals 24. So 24 is our output. Again, this is a coordinate pair. If we were talking about the graph of this function, we would have a point on our graph at this place. 5 is our input, 24 is our output. So these things are all sort of connected. And if we had a table for this function, where we had our inputs and our outputs, we could use some of these things to help us create a table. Well, we have one right here that's input of -3, output of 8. And here's another one, an input of 5 and an output of 24, right? We could start to create a table this way too. Anyway, that's it. Make sure to work on the Delta Math assignment. A lot of practice with evaluating functions on tables and graphs there. And I'll see you guys in class.